Okay, and today we are looking at arcs and chords and some properties of arcs and chords. The first thing we're looking at is if we've got a diameter or a radius of a circle and it's perpendicular to a chord, then it bisects the chord. We see that example right here. We've got a circle with a radius or diameter, and we have a chord here, and we're saying that if it is perpendicular, it's going to split that chord into two congruent segments. Now, also, the perpendicular bisector of a chord, if we have a chord and we draw the perpendicular bisector, well, that perpendicular bisector is going to be the diameter. Or radius. So that's the first point we're going to talk about. The second one, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So here in this example we have our circle. We have a chord here and we have a chord here. And we're saying that these arcs are congruent if the chords are congruent. Okay, and the last new point for this lesson, in the same circle, and also what that also means is if we have two circles that are congruent to each other, and I draw a chord here and a chord here, and I say that the segments are congruent, well, that means the arcs are also congruent. Okay, so it doesn't matter if it's two chords in one circle or two chords in two different, keyword is congruent circles. In the same circle in the congruent, in this next section, in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. And what that means is if they are the same distance from the center, then the chords are congruent to each other. And likewise, if the chords are congruent, then they're going to be the same distance from the center. Let's look at a few examples. Here's our first one. We have two congruent circles. We have information that says that the arcs are congruent. So if the arcs are congruent, then the corresponding chords are also going to be congruent. So we can set those equal to each other. 7x minus 2 is equal to 5x plus 6. 2x, solve for x equals 4. That's not my answer. Remember, they're asking us to find the length of wx. Well, wx is 7x minus 2, so 7x, which we found to be 4, minus 2. It's 28 minus 2. That means that segment wx equals 26. All right, and that's how we use that information to solve problems, solve for values, find lengths. Okay, let's look at another example. We've got two chords, or one chord and a radius. Notice that the radius is perpendicular, and it says that DEF, this arc right here, is 150. We need to find arc DE, so this one. Notice that this chord is perpendicular to the radius, which means it's bisected, so that segment's equal, congruent to that. And if the chord is bisected, the arc is also bisected, which means both of them added together equals 150. So we're going to divide 150 by 2 to find the measure of arc DE, which 150 divided by 2 is 75. Alright, now we have a tile. This one's a little tricky. The diameter AB is 18 inches long. I'm going to zoom in on this one. Okay, so the diameter, and I'm going to use, let's see, I'm going to use black. That one seems to show best on this. The diameter is 18, which would mean that the radius is 9. Now it says that EF, chord EF, is 8, which it's perpendicular to the diameter, so the chord is bisected, meaning if it's 8, then each half is 4. Well, we need to find the measure of CD, that segment right there. And we don't know what that is. However, if we make a triangle here, we end up with a right triangle. Now CE, that segment I just drew to create a triangle, that's the radius, so we end up with a 9 there. So what we actually end up with is a triangle that has a hypotenuse of 9, a leg of 4, and the leg unknown that we're looking for. So if we use the Pythagorean theorem here, we can solve for that length CD. And we will do that. X squared plus 4 squared equals 9 squared. Sorry, that should be plus 16. X squared equals 65. And if we square root both sides of that, we can't simplify that radical. So segment CD equals radical 65, or 8 point something. Alright, that's a tricky one. Let's look at the next one. We have a circle, and it says that EF and GH are congruent, which means EF and these two segments are congruent to each other, which, based on one of the things we learned, the distance to the center of the circle is also going to be congruent. So 4x minus 3 is equal to 2x plus 3. We're doing this to solve for x. So once we solve for x, we can plug that into PQ, which is 4x minus 3. So 4 times x, which is 3, minus 3. We find that PQ equals 9. Okay, and then the last example that we have two chords, WX and XY, that are congruent. So the distance to the center of the circle is also going to be congruent. So 5x is equal to 3x plus 4. Solve for x. X equals 2. We're finding AB. AB is 5x, so we're going to plug in 2 for x. 5 times 2, and segment AB is equal to 10. Okay. Looking at the homework assignment, number 3, what you're going to do there is, remember, you're looking for x. The radius is going to be 12 because the diameter is 24, so the radius is 12. So this full length is 12. To find out what x is, we're going to have to take 12 and subtract 6.7. Number 5 and 6, that one's tricky. You're going to be looking at, the radius is 15, or this segment chord is 15.2, but remember they're congruent because it's bisected by that the radius, which is perpendicular. So this is also 15.2. So to solve for x, you're going to use the Pythagorean theorem. X squared plus 15.2 squared is equal to 16.4 squared. And 7 and 8 is just like that. After that, when you get to, or 9 is the same, 10 is a little bit different. we know what the radius is, so it's similar to 3 and 4, but we don't know what this value is right here. If we knew what that y value was, we could subtract it from the radius to solve for x. So you're going to use the Pythagorean theorem to solve for y. So 7.7 squared plus y squared equals 9.3 squared. And once you do that, you're going to find y. If you know what y is, you can subtract it from 9.3. And that will give you your x squared. Similar to that is 11, you're going to use that y there. 12, you're going to use that y. Okay, and the last page, you're looking at those examples. Use the information we learned. Number 5 might be tricky for you. What we've got there is the chords are congruent, therefore the arcs are congruent, which means this arc is also x. If BC is 114, we take 114 from 360. And that means that these two x's have to equal 246. So 2 times x equals 246. Basically, we're just dividing 246 by 2, and we find that x is 123. Okay? Hopefully that helps.